In this video, we're going to review for the quiz on sections 11.1, 11.2, 14.1, 14.2. And the way I'm going to do this is I'm going to show the work that's required to do the two review worksheets that we've had in this unit. I'm going to start with the one that's called Review 2 and walk through the answers on that. In number 1, made a circle that had the center point of O and drew a radius from the center to the edge, drew a diameter from edge to edge through the center, and a chord from edge to edge not through the center, and labeled all those points. In the second problem, drew another circle with center at O and central angle AOB. That's a central angle because it turns in the center. And inscribed angle ADB is inscribed because it turns on the edge of the circle. What's the relationship between these two sizes? This angle right here, the central angle, is twice as large as the inscribed angle. For instance, if the central angle were 80 degrees, the inscribed angle would be 40 degrees. Also, the minor arc, that would be minor arc AB, would also be 80 degrees, the same as the central angle, and twice as large as the inscribed angle. Also, the major arc, and the major arc would go around the long way, and because of that, we need to use 3 letters, and that answer will always be bigger than 180 degrees. It could equal 180, but most of the time bigger, and in this case, it would be 280, and that's because all the way around the circle is 360, which is made up of the 80 plus the 280. Minor arc, major arc. In the next two problems, numbers 3 and 4, in each case we have two things, radius and diameter, and the diameter is twice as long as the radius. Inscribed angle and central angle. And the central angle is twice as big as the inscribed angle. So in each case, our equation, our algebra equation, would be exactly the same. 2 times the little guy equals the big guy. And we can solve out for x. X is equal to 9, but don't forget what the question is. What is the length of the radius? So I have to plug 9 in. What is the size of the inscribed angle? So I've got to plug 9. It's going to be the same answer, same equation. I have to plug that into my inscribed angle. And I get the same answer both times, 34 for the radius and for the inscribed angle. In the last problem on the first column, we have a chord that is located 5 centimeters from the center of a circle. So there's our chord right there. And there's our length from the center of the circle, 5 centimeters. It's the shortest length. It's the length that meets at 90 degrees. And when that happens, it divides the chord in half. Half here and half here. That'll always be the case when it talks about being located from the center. The diameter is 18, so that's 9 on this side and 9 on this side. What is the length of the chord? In this problem here, we're going to use the Pythagorean formula. We have a nice right triangle right there. So that'd be a squared plus b squared equals c squared. So anytime you got length from the center, chords, diameters, radii, it's going to be a right triangle. Just make sure that your diameter, half of your diameter, is the c. X is equal to 7.49. That's not the entire chord, that's only half the chord. So I have to double it to get the full length of the chord, 2 times x to get my answer. In our next problem, we also have a chord and a circle. So the radius is 5. There's the radius, center to the edge. The chord is 8. So when we have the distance from the center to the chord, it will split the 8 into 4 and 4. Now I have a nice right triangle that I can do my Pythagorean formula on. And when I do that out, I get that x is equal to 3, and x is the distance from the center, so I'm done. In question 7, I have these two arcs. The arcs are the same amount of degrees. So here are the segments. So how do the segments compare? If the arcs are the same, then the segments are also the same length. So we put the two algebra pieces equal to each other, solve it out, but don't forget to answer the question, what's the length of CD? So plug it in to get your final answer. In question 8, we have an inscribed angle, 3x minus 2. That's inscribed, so it turns at the edge. And a major arc going around the back way, ABC, 10x plus 8. If the inscribed angle is 3x minus 2, its intercepted arc out here is twice as large, 6x minus 4. We have to double the inscribed to get the arc. The 6x minus 4 combined with the 10x plus 8 brings us all the way around the circle, so that adds to 360. In question number 9, we have two tangent lines, or tangent segments, would probably be a better way to say it, that are to the same circle, and they meet at point B, and their points of tangency, so that's where they hit the circle, are A and C. They hit at 90 degrees. Tangent lines hit at 90 degrees. If the central angle is 50 degrees, AOC, how big is angle B? Well, what I have here is a quadrilateral. That is 4 different sides. And when we have a quadrilateral, the interior angles add up to 360. That's a 90, a 90, a 50, and something we're trying to find out. So here are my equations, and I can solve both of them for x. In question number 10, we have a central angle. We have an inscribed angle, turning on the edge. We have a minor arc, which only requires 2 letters. A major arc will require 3 letters and should go at least halfway around. B, C, D. 3 letters for major. A radius, AC, but we have 2 other radii we could use. A diameter, BD, and a chord, BD, so the diameter is BC. In question 11, we have 2 inscribed angles, WZT and WYT. Notice they both have W and T, so they both start and end at the same 2 points. If that's the case, they have the same intercepted arc, WT, and the 2 angles are congruent to each other. So we can set them equal and solve for x, and then figure out our answer. When I solve it out, I get that x is equal to 2.5. I need to figure out the size of the central angle. That's WOT. O is our center point. Well, I can plug in x to figure out the size of my inscribed angle, which would be 13.5 degrees. That's the inscribed. But the central angle is twice as large as the inscribed. So once I know the inscribed, I must double it to get the central angle. So that's one of the most important points from this unit, is that a central angle and an inscribed angle are not the same size. Central angle is twice as large. In question 12, we are told that this angle right here is 65 degrees. That's an inscribed angle. So from ending to ending, from E to B, is double the inscribed angle. So that's 130 degrees right there. We're also told that this arc right here is 135 degrees. So this piece over here completes the entire circle. So that is what adds up to 360. So 360 minus the 2 we know gives us the remaining piece. And now we're ready to answer our questions. All right, so let's look. CB, we've already found that's 95 degrees, so that we make a circle. Angle DAB is a central angle. It's a central angle, so it's the same as the arc length. Well, we know that this arc length is 95, and we know that this is a half of a circle, which is 180. So that would be 180 minus the 95 to get us this little piece here, part of the 130. For our last question, ECD, well, can I do the same thing? Can I take a half of a circle, which is 180, and minus the 135, and get the answer, which is 45 degrees? Well, no, because an inscribed angle is not the same as the arc. The inscribed angle times 2 is the arc. So I need to take my answer over here of 45 degrees, that's the arc, and I need to cut it in half to get the angle. The inscribed angle has to be doubled to get the arc. I'm going to skip question 13 because it's least likely to come up in the quiz. But in question 14, we have been given one arc length, another arc length, and an inscribed angle. We have to double the inscribed angle to get the arc length. All three arc lengths add up to 360. Here's our equation, and I think that you could finish it from here. In this problem here, we have a central angle, ROQ, an inscribed angle, RPQ. They do not equal each other. The central angle is larger than the inscribed angle. You must double the inscribed angle to equal the central angle. We can now solve for x, and we can plug x in to the central angle. The central angle is 117.33 degrees. But we are not being asked for that. We are being asked for the major arc around the outside, RPQ. Remember, a major arc has 3 letters and is larger than 180 degrees. As you can see, it's really, really large. But together with 117 and the major arc, they make 360. So 360 minus the minor arc equals the major arc, 242.67 degrees. All right, here's our last problem that we're going to do. And we've been given a segment length, UT, a radius length of 7, and an angle, TUV, of 35 degrees. What we should do here is we should complete the triangle, because we know that that will be a right triangle where a tangent segment hits the point of tangency, and then I think we can figure some stuff out. All right, so the right triangle has been completed. Here it is. I can use my Pythagorean formula on right triangles. This is another radius, so it'll be the same as this radius of 7. 7 squared plus uv squared equals 12 squared, and we can solve for uv. Also, because a triangle has 180 degrees, and this one's 90, and this one's 35, I can figure out what the central angle is. 55 degrees. So I have solved out my Pythagorean formula. I could leave my answer as the square root of 95, or I could do it on my calculator and get 9.75. Remember that if there's units here, like centimeters, I should probably put centimeters at the end of the answer. Also, because I know my central angle is 55 degrees, that's my central angle, that is the exact same amount of degrees as is in the minor arc. So if that's 55 degrees, that's 55 degrees, and I have my answer. I think if you look over the problems on this video and maybe skip back and relook at a couple of these, the quiz questions will look very similar to this when you take it later this week. Good luck.